Okay, so now let's move on to the linear independence of polynomials. So we just going to take the idea that we got from the last videos, the last method, and also extend it to this one here, because it's one and the same thing. So here actually it's like you're dealing with polynomials, so you want to check whether these polynomials are linear dependent or linear independent. So we're still going to use the same strategy, but in like extended way. Okay, so it says, let's just jump to a actual example. It says determine if the following set of vectors are linear dependent or linear independent. So you have A, which is P1, you have a P1 and P2, and P3. So also that was supposed to be P1, which is 1, and P2 was supposed to be x, and P3 was supposed to be x squared. And then they say that are in P2. So if now for the polynomial something different, if vectors are in P1, therefore it's like you have a 0, 1, and you add that by 0x. So this is a P1 of polynomials. Remember what are polynomials? Polynomials, if are given by this function here, this function an multiplied by x to the power n, you add that by an minus 1 multiplied by x n minus 1 plus up until 2 this one a1 x1 plus a0. Remember, this is a definition of a polynomial. Why? Because let me just give you an example of a quadratic polynomial. So it's going to be x squared plus, let's say we have 2x plus 4. You see, so here the degree of x is decreasing by 1. Was n minus 1, and then at some point this is 1 here, and then it's going to be 0. It's like here you have x to the power 0. Okay, so this is from maths. Then now we're going to take these polynomials and check if they're linear dependent or linear independent. So the polynomials in P2, since this is P2, remember that it's given by a2 or 2 plus a1 x to the power 1 plus 0 x to the power 0. So this is a polynomial in P2. So meaning that always we take the a1 is 0 always for linear independent and linear dependent. So a1 is going to be 0 x squared plus this is going to be 0x plus a0. You see, so it's like a0, since it's 0, therefore it's going to be 0. This is 1, 0, 1. So I just write that in a reverse way. So it's going to be p of 2 is going to be 0x squared plus 0x, or you can write it in any order. All right, so now let's take a look at this one. So we're going to use the same analogy. We say that k1 multiplied by p1 plus k2 multiplied by p2 plus k3 multiplied by p3 is equal to, since they're set in p2, so if 2 is going to be equal to, this is going to be equal to 1 plus 0x plus 0x squared. So I'm going to write this as k1 open bracket, I have 1 here for k, plus k2 for p2 is x, plus k3 for p3 is x squared. This is the same as 0, 1 plus 0x plus 0x squared. Then after that you equate the corresponding components. So this is k1, so k1 correspond with this one here, so k1 is going to be 0, and then this is k2 correspond with this here, so this is k2 is going to be 0, and this is k3 correspond with this, k3 is equal to 0. So therefore this tells us that this system of polynomials has only trivial solution. This is a trivial solution from our previous video. If you can go and check that, this is a trivial solution only. Therefore, we say this system or these polynomials are linear independent. Independent. Why? Because they have a trivial solution only, therefore they're linear independent. So let's do the second one, B. So second one, B, is here. So it's going to be P1 is x minus 3, P2 is going to be 2x minus x squared, and P3 is going to be 1 plus x squared. It's also in P2, so it's in P2. So therefore we're going to have K1 multiplied by x minus 3, and then you have this plus K2 you multiply by 2x minus x squared. You have plus K3 you multiply by 1 plus x squared. This is also going to be 0, 1 plus 0x plus 0x squared. Okay, so here you take this, the components that are the same. So you have this one, this multiplied by this is kx. So you're going to have x k1, and you add by the component that has x also, is this one here, plus k2, or supposed to be 2x k2, then you add by another one. We have no another one. Okay, so these are the one and the same thing. Then you go for this, which is going to be minus 3 k1, and you check for another constant, which is this one, plus k3, this one here, right? So then you add by the last one, which is going to be the one of x squared. This is going to be minus k2x squared. Then you come here, it's going to be plus k3x squared is equal to the same thing, is equal to that. I don't have a space there, but you can write it. It's equal to this. It's equal to this thing here. So therefore here you can take x out, and here let's start by that one. So this one is going to be minus 3 k1 plus k3, which are these, plus we add by this one. You take x out here. So if you take x out, you are going to be left with k1 plus 2 k2 multiplied by x, and then here you take x out, or x squared out. So you're going to be left with k3 minus k2, and then you have x squared. So this is equal to 0 into 1 plus 0x plus 0x squared. Okay, so the corresponding coefficient, this coefficient here correspond with this 0 as we did last. This one here correspond with this 0, and this coefficient here correspond with this 0. So therefore you have a system of equations. You can write that as a system of equation is minus 3 k1 plus k3 is going to be 0, and then you have k1 plus 2 k2, this is going to be a 0, and you have k3 minus k2, this is going to be 0. So you can set a matrix, or you can set a system of equations using this one. Remember that you can say this is the same as k1 yes minus 3 0 and 1, k2 is 0 here, and then you have 1 2 and 0, and you have 0 minus 1, and k3 is going to be 1. This is a system of equation. You can say this is multiplied by k1, k2 and k3, and correspond to 0 0 0, and you can find the values of k. So when you get the values of k, it's where you are going to determine whether this system is linear dependent or linear independent. Okay, so let me just copy this and go and solve it for you. Okay, and also feel free to pause the video and try by yourself. Okay, so let's do it. Here we're going to reduce this. We're going to do triangular matrix. So we're going to make this 0, we're going to make this 0 and make this 0, right? So by doing that, that means we're going to solve this matrix first. We have this matrix as 3 0 1 and 0 2 0. Okay, here's not 0, it's 1 2 0 and 0 minus 1 1. Okay, so here I want to make this 0. First thing, I can just switch these two rows, since this one already has 1 and I need 1 here. I can say this row 1 exchange with row 2. Remember, this is a row operation and it has no effect for doing that, so it's going to be this now, and minus 3 0 1 0 minus 1 1. And now I can say this row 2 will turn to row 2 plus 3 row 1. You can see when you multiply this by 3 you get that. So this is going to give me 1 2 0 and 0, row 2 which is 0 plus 6 from this one here when you add these two, and then this is going to be plus 1. So this is still the same as 1 minus 1. I want to make this 0 here now, this one 0. So to make that one 0, I can just use this one here to make it 0. So I can say this is the same as first divide this by 1, so it can be easy. You can say row 2 is going to be row 2 divided by 6, sorry. You divide this by 6 to get 1 here. So it's going to be 1 2 0 0 1 1 over 6, and then here you get 0 minus 1 1. But here you can also solve this. By now you can solve it. So if you solve this, you can say for this one here, now it's a matrix, you can come and substitute in here if you don't want to waste time, because solving it to a row lower upper matrix is going to waste you time. You can just solve it. You can just go take this matrix and put it here now, and it's going to be 2 0 0 1 1 over 6 0 minus 1 1, and this is multiplied by k1 k2 and k3, which is the same as 0 0 0. Okay, so here let's start with this one. So here you can see you can take this multiply by this, get 0, take this multiply by this, get 0, take this get minus 1, take this multiply by this, and you get 1. So it's going to be minus k2 plus k3 is equal to 0, correspond to this one here, correspond to this. So here you can just let k2, okay, let k2 k3, sorry, not k2, let k3 be t. So if k3 is t, what's going to be k2 then? Since k2 is equal to k3, therefore k2 also is equal to what? T. Both of them are equal to t. So you can solve k1 then. So you have a t, and a t is element of all real numbers or any real number. Okay, so let me copy it. Paste it here. Okay, so we can solve for k1 from this one. So from this one here, when you take this, you multiply by this, we're going to have k1 plus 2 k2 plus okay, so you can take it further by making this 0 here. So to make that 0, you can say let me see, you can say that this is the same, r3 will tend to r3 plus 1 over 6 r2. So this is going to give you, this is 1 2 0, and then this is 0 6 1, then this is going to be 0. So this and that, when you're using that, it's going to be 0, and then you multiply this, is going to be 1 over 6, and you add it by 1, which is going to be 7 over 6. Okay, so here you have 7 over 6. So now you can take this back to here, to this position, and try to find for k. So when you take it back to that position, you're going to have, when you take it back to there, you're going to have minus 3, 0, 1, 1, 2, 0, 0, minus 1, 1. So you multiply it by, okay, so I was supposed to write this here. Okay, I was supposed to substitute it once because waste time. So let me just paste it here. Okay, so I paste it here, and then I'll copy this. I'll copy and I'll paste it here so that I don't waste time. Okay, so here remember was k1, k2, and k3, so it gives you that. So there is clear that if we take it from here, we're going to have 7 over 6 k3, which is equal to 0, and then k3 is 0, right? But from this one, we're going to have 6 k2 for the second one. When you multiply this and that, you're going to have 6 k2 plus k1 is equal to 0. So you have plus k3, sorry, not k1, plus k3 is equal to 0. You have k3 already 0, so you have 6 k2 plus 0 is 0. So k2 is gonna give you 0 also. Okay, so you come back if you got 0 here, and then you come back for this one, for the first one. So for the first one, you have 1 k1 plus 2 k2 plus k3. No, plus 3, not 3. 0 k3 is equal to 0. So you have that k2 is 0. So already k1 is going to give you 0. So okay, so the only solution that you have is a trivial solution. So if you have a trivial solution only, you're going to say that this system of vectors are linear independent. So the vectors are linear independent. That. Okay, so we are done.